Hello, my name is Christopher Reitvier. I'm the head of digital construction in the city of Tallinn, and today I'm giving you a brief overview of what is Tallinn Digital Twin Platform, why are we doing it, and when are we actually starting to implement it. We are looking at it from the perspective of the urban environment and digital construction. So first of all, what is digital twin overall? How are we understanding it in Tallinn? There is a physical world with its data. We need to capture the data by using remote sensing, laser scanning, photogrammetry, various Internet of Things devices and sensors, also self-driving cars. And when we have the data, we need to analyze it, make it better, so make it richer, make it usable. And for what do we have to make it usable for? Decision making. This is the core of the digital twin, to make better decisions based on better data. This can be human process, but also we can use the artificial intelligence in doing that. For example, machine learning, neural networks, machine vision, and so on. But we can't make it entirely machine process. We still need human in that. For example, if we have to make the difference between Chihuahua and a muffin, seems quite easy, but for the machine, it's not that easy at all. And by starting to look at this picture, it's also perhaps with some choices not so easy for the human being. So there are a lot of false positive, false negative results, which human needs to correct so that in the next stages, machine can make better decisions based on the data given to it. But looking at this process from the data capture to the decision making, as a one-way street, we can't talk about digital twin. This process is what we call digital shadow. And if we want to turn the digital shadow into a digital twin, then we have to make this process circular, going back from decision making to the data capture, and also from data capture to decision making and back again. Digital twin, we would say, is a spatial data technology system that is the technological foundation of a smart city. And so, from the term, actually, what the digital twin itself is, what it is in Tallinn, and why do we call it the framework, not just the digital twin. There are three fields: data, the fields, the services. For example, for the data, we don't have this kind of one magic database of Tallinn data. There are several databases with the different data structure. Of course, then we also have the national data coming from the building registry, also from the land board, and from the planning registry. And for some other services, we can use some other databases, but we also always have to know that the data that exists in this original source has to be the original source of the data. We can't duplicate it. When we use the data, we make changes to this data, we have to send it back to the original source. Talking about the fields, for example, the energy, very important. We are facing the climate crisis. This is the fact. And we have to make the things better. For the energy field, how can digital twin help? For example, we can make a renovation calculator, which is basing of the data coming from the energy consumption monitoring, for example, which kind of buildings we need to renovate faster, with which we can have a little bit more delay time, and also to use the solar energy potential to simulate it. How can the solar energy help us by becoming the users of more clean energy much faster? And for that, we can also use the city model, so another aspect of digital twin. And of course, there are the different other fields like the city planning, city property, the roads and the streets, the greenery, with all the different services that are related to these fields. Of course, there is a lot of mentioning of BIM, BIM-based planning, BIM in design, BIM in construction, BIM in maintenance. So I would say that the BIM means building information model, modeling, or management. This is basically, I would say, it's like a 3D model, but without just the 3D mass. every element knows what it is. The walls know their walls, the windows know that they're windows, and what are the different physical properties, parameters related to these elements. Of course, we need to monitor the condition of the roads and do mobility analysis, so our street network would be usable to every citizen in Tallinn. With the landscaping, greenery, we have to take effect into the dynamic nature of these elements. For example, if we're comparing the houses and the trees, house is like it is, the building. It is how it is built. It changes only when we start adding to it by extra building, renovating it, reconstructing it, or demolishing it. But the trees, they are growing, and not only above the ground, but also below the ground, so that tree roots can get into the conflict with the foundations of the building, also with utility networks and some other kind of devices. And for that, we can make also better decisions what to use. And these services, although they are separate services, they're all linked with each other because they are very much part of the building life cycle or the urban environment life cycle. Therefore, all these services combined, they form this kind of like digital twin platform. So why? Why are we doing the Tallinn digital twin? There are three pillars. We have to fulfill the objectives of the strategy of Tallinn 2035. Digital twin helps us do that. There are different benefits to be obtained, like the quality of decisions that I was talking about a few slides before. This makes greater efficiency, like lowering the cost and increasing the productivity. And also this kind of like systematicity of the views. Also, the wider view of the digital twin would be to enable the technology development, supporting the development of the digital society, and also carrying the complexity of an increasingly complex world by technological means. Because the world we're living in is getting more and more complex with each day we're living in it, because we're living in this kind of like information society. And I would say perhaps we have too much information. It's becoming already a background noise. We have to start picking what we actually need. Some advantages of Tallinn. We have digital society. Also, already using the digital signature in Estonia is saving 2% of the GDP every year. There are only two services provided by the state or the city that I know that are not digitalized yet, like getting married and getting divorced. For these kind of things, you actually have to be there in person. Like if you want to vote for your government, you can do it at your home, behind your computer, using your digital signature. You can buy your house like that. Also, the private sector is quite strong. We have the most unicorns when talking about the startup world per capita of the people. The city size is just right. It's not too big, it's not too small. We have a strong cooperation with the city of Helsinki, capital of Finland, also very strong, innovative place. And together we can invent this wheel so much faster than doing it separately in our different rooms. Also, we have strong education and research institutions and proximity to the state level. So some example about mobile data capture that I was talking about before. For example, we have a car, 360-degree camera, a little bit of machine learning, and we can already see that what is actually there in our roads. How many potholes, how many cracks. You can see that every crack that we have discovered has their unique ID and also the place that they are situated in. And also there is a picture, we can see the same place from the different angles to decide how big of the crack it actually is. So, but another point of why we are doing digital twin is because we want to be a smart customer. City needs to be a smart customer because the creation of the high quality living environment takes place through competencies that can be guaranteed by a smart customer and strong companies. So they can do it only together in symbiosis. But not every kind of symbiosis is healthy. So I would say that the only way to lead to high quality living environment is through the mutualism. We have to have a smart customer and strong companies. So positive and positive. Commensalism and parasitism, unfortunately, are not the way to deal with it. So when are we actually implementing these services that I'm talking about? This year, we're doing the mobile data capture of the whole city. We're finishing the Green Twins project, becoming to the detailed green models, these dynamic calculations, doing the solar energy analysis, and also improving the planning registry with enabling these kind of like 3D BIM-based detailed zoning plans, having the proof of concept at first. And in the background, we also have to deal with the processes to create a network for digital twin, activate these product owners, create these kind of technical specifications and framework. And the implementation of these new processes is extremely important. But then do the case studies, the different case studies from the field of construction. For that, I have to use this kind of graph. The Tallinn BIM, Tallinn in Building Information Model, Modeling or Management. So the BIM again. Starting from the detailed zoning plans. This is where the journey begins. This is what happens in the urban environment. Then when we have the planning, we design the construction. We have been doing it in BIM quite a long time already. With the planning, I will give you a slight overview in the next slides. And when we have the design, we need to get the building permit. We want to do it BIM-based permits. Then we have to use the BIM in the construction to actually get the best of it. After constructing the building, we need to get the certificate of occupancy. We want to do it also BIM-based. Then have this building in our city model, in the 3D city model, so the digital twin viewer, I would say. Then using it in the facility management, also again in demolition. And when the building has been demolished, again, there has to be the same time representation in the digital twin, so in the 3D city model. But going to the planning, the foundation of the building life cycle, where are we now? I would say it's a long process. It's quite long in Tallinn. It takes several years to get this kind of planning enforced. We are using the PDF and doc formats for it, which are not machine readable. Therefore, also we have some kind of like unreal illustrations that are not giving this kind of like understanding what is actually being built. And participation by using these 2D materials, I wouldn't say it's user-friendly, I would say it's completely user-hostile. And by doing it, we have to ask, is this really how we get the best urban environment? I would say no. As you can see, the main drawing of the detailed zoning plan, more than 50% of this drawing is the legend how to actually read this drawing. So what is the solution? I would say planning information modeling, also known as BIM-based planning, not so widely used term in entire world because it's quite new. We did 2 pilots, one for Järve Towers and one for Estonian National Broadcast Building. The National Broadcast Building, this is the thing that you're seeing here in the background, this 2D thing. If you can just have it back of your head when you're seeing the next slides. Järve Towers, we added them to the city model to see how it looks visually. But with this National Broadcast Building, we took a step further. And for that, I'm going to show you a small video, how it actually looks like. So we have the different layers of the planning. For example, the area, the buildable area. This is not just 3D, it's also the data. For example, the absolute height, the number of building stories, the depth, how many building stories can there be below ground, and so on. Then we have this greenery, the trees. It's not just this kind of like tree models to look beautiful, but it's also the data. Like, for example, there can be what is the value class of the trees, what are the species, what is the width of the tree trunk, what is the width of the tree crown, also information about the roots. We can have the information also about the transportation layers, I would say like which area is usable only for pedestrians, which can be used for cyclists. But even though if we are doing it like this, there are a lot of white boxes as you were seeing. But if we switch these white boxes into actual texturalized environment, how we are seeing it in our everyday life, then it's not usable only for the architects, but for the regular people who live there in these streets, in this area, and they can actually see what's going on there, what's happening. And also we can have this kind of like utility networks visualized. What is the protection area of these utility networks? And then just zoom in and see visually. We can also do automated checks, but at the moment we have to look at visually. We don't have automated checks in place. Like, can there be possibility of the conflict between the roots of the trees and the utility networks? But again, if we have a gray box of buildable area, and already we have this kind of building information model in IFC Industry Foundation classes format, the open standard, and we have added it into our viewer. Then again, we can either look it visually, manually, or we can do it automatically. Is it fitting into the buildable area? And also for the building, it's so much more easy to just look what the developer of this area wants to build there. It's giving so much more information than just a gray box. And by developing these tools further and further, I would say that this would be something that needs to happen everywhere, because like you saw this in the video versus this kind of like hedge on top of hedge from the 2D drawing that you saw a few slides back, I would say there is a huge difference. We have to move towards simplification. And now the BIM in construction. So we are not using the BIM only in the planning phase. We are doing already the construction design. In Estonia, we're developing the BIM-based building permit system so that we actually could get the building permit based on the BIM model, not only the 2D drawings and the explanatory letter, which is like a huge text document. And to use the BIM in construction with its full potential, we have been doing this kind of BIM technical requirements for our contractors to fulfill. We have implemented the common BIM requirements that are the BIM requirements for entire country. We're not doing the BIM only for the buildings, but also for the facilities and the infrastructure, so the infra BIM. And what is extremely important for us is to use the BIM in facility management, so the BIM FM. Because the facility management is actually where the most costs of the building take place. And this is like the main place to get a really good victory out of that by using the BIM processes. We have been creating 2 innovation project manager working positions, one into the city property department and one for the environmental and communal department, to make these processes faster, to implement them faster, and to have this kind of competence in this technology field in these departments. And further on, I was talking about the common BIM requirements and the Tallinn Building Information Management. In order to get the best out of BIM, we have to have the correct geolocation. We need to fulfill the building registry's requirements to get the BIM-based building permits. We have to be aware that these softwares that our contractors are using are able to bring all these common BIM requirements in life. We have set the level of the geometry of the different details that we want for the elements in the different stages of the construction design. We have been demanding the reports of the clashes and the data that exists there from the contractors to be aware that these models that are presented to us as a customer are meeting all the requirements that I was talking about earlier. And also, we are mainly using the open formats like the IFC, but we need also the native formats so that we can more easily use the BIM in the different aspects of the life cycle. So what is BIM actually helping us to prevent these kind of mistakes in the construction site so that the ventilation and the canalization are clashing? or the water and the ventilation are clashing, because at the construction site, these mistakes cost so much more money than just preventing them from the construction design stage. But with a good construction design, we can ensure that these kind of mistakes are not happening in the construction site. And how can we do it? Not alone. We have to have the good collaboration with academia, with the Tallinn University of Technology, Tallinn University of Applied Sciences, and we have a quite good collaboration also with Cambridge University. This is something we're very proud of, to trust the academia, trust the science behind it. Also, the digital construction cluster in Estonia is a very strong partner to us. The proximity to the state level that I was talking about earlier, the ministries of economic affairs and communications and the Ministry of Finance. Also, we have the public sector procurer working group to do the things together. Internationally, we're developing the digital twin together with Rotterdam and Helsinki, learning from each other. And of course, we need a strong private sector to be there for us, because if we are setting the requirements and there is nothing coming back to us, then this process is not possible. Thank you very much for your attention, and in case of any questions, you can always write me an email and I try to answer as soon as possible. Thank you.